Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized pieces. Today, we're diving into the world of medicine, artificial intelligence, and a challenge that affects millions of people, yet is often invisible.
We're talking about rare diseases. Individually, they're rare, by definition, but collectively they affect an estimated 3.5 to 6% of the population. That's hundreds of millions of people worldwide. And for these patients, getting a diagnosis can be an agonizingly long journey.
It's often called the diagnostic odyssey. Patients can spend years, sometimes a decade, bouncing between specialists, getting misdiagnosed, and undergoing countless tests, all while their condition might be getting worse. The problem is that the symptoms are often vague and can look like many common illnesses.
Exactly. And a family doctor might only see a case of a specific rare disease once in their entire career, if ever. So how can we expect them to recognize it? It's a classic needle in a haystack problem. This is where a new paper titled RareLens suggests we can use AI to build a much better metal detector.
Okay, so we've heard a lot about AI and medicine. The idea is you feed a patient's symptoms and history into a super smart large language model, or LLM. Think of systems like ChatGPT or Gemini, and it helps the doctor figure out what's going on. But this paper argues that just using a single AI, no matter how smart, isn't the best way to do it.
Right. They have a really clever twist. Instead of asking one expert, they ask a whole panel of them. They take a bunch of different powerful AI models and give them all the same patient case. And here's the crucial insight. They don't look for where the AIs agree, they look for where they disagree.
That sounds counterintuitive. Wouldn't you want a consensus? If all the experts say the same thing, that's usually a good sign.
You'd think so, but the researchers found that the disagreement, what they call divergent reasoning, is actually incredibly valuable. Think of it like a medical consultation with a team of human specialists. A cardiologist, a neurologist, and a geneticist will all look at the same patient, but focus on different clues. They bring different perspectives. The disagreement isn't noise, it's information.
So these different AI models, because they were trained differently, have their own unique perspectives. One might be better at spotting subtle neurological signs, while another might pick up on a pattern in the blood work.
Precisely. The RareLens system is built on this idea. First, it gives the patient's case to a panel of diverse LLMs. They all come back with their own ideas, creating a wide range of possibilities. That's the divergent part. Then a second layer of AI acts like the head consultant. It analyzes all these different, sometimes conflicting opinions and intelligently combines them into a single, more accurate final decision. It aligns their reasoning.
So it's like having an AI-powered version of the TV show House, with a whole team of brilliant argumentative diagnosticians and one final AI to make the call.
A perfect analogy. And what's really impressive is that RareLens doesn't just stop at diagnosis. It's designed to support the entire patient journey. It's broken down into 4 parts.
Let me guess. It starts with just flagging that something might be wrong in the first place.
You got it. The first module is called Rare Alert. It's a screening tool for the very first doctor's visit. It looks at the initial symptoms and history and just answers one question. Is this patient at high risk for any rare disease? This is the step that's so often missed in real life.
Okay, so if the alert goes off, what's next?
Then you move to Rare Diagnosis, which generates a list of possible rare diseases and recommends tests. After the tests are done, it helps narrow it down to the final diagnosis. From there, Rare Treatment suggests personalized management plans. And finally, Rare Prognosis helps predict the patient's long-term outlook. It's a complete end-to-end system.
That's a huge step up from just helping with one piece of the puzzle. But the big question is, does it actually work?
The results are pretty staggering. First, to even build this, the researchers had to create a massive new dataset called RareBench with over 150,000 real-world medical cases. When they tested RareLens on this data, it outperformed every single one of the powerful individual AI models, including systems like GPT-5 and Claude 3.7, at every single stage.
So the team of AIs really is smarter than any single genius AI.
It seems so. But this is where it gets really interesting. They then ran a study comparing RareLens to 23 practicing physicians. They set up 3 scenarios: the doctors working alone, RareLens working alone, and the doctors working with assistance from RareLens.
I would assume the doctors assisted by the AI would do the best, human expertise combined with AI power.
That's what most people would think, but it's not what happened. The unaided physicians, as you might expect, struggled most, catching only about 33% of rare disease cases at the initial screening. But the best performing clinician in the study was RareLens all by itself.
Wow, so the AI on its own was better than the doctor AI team?
Yes, the doctors who got help from RareLens did much better than when they were alone. Their accuracy roughly doubled, but they still didn't reach the performance level of the AI by itself. The paper suggests this might be due to things like algorithm aversion, where humans tend to mistrust AI advice if it feels too strange or counterintuitive, which is exactly when it might be most valuable for a rare disease.
That makes sense. If an AI suggests a 1 in a million disease, it's hard for a human to override their own intuition.
Exactly. The big takeaway from this paper isn't just about a new tool for rare diseases, as incredible as that is. It's a fundamental shift in how we think about using AI. The goal might not be to build one single perfect AI that knows everything. Instead, the real power comes from harnessing the diversity and even the disagreements of many different AIs.
It's the wisdom of the AI crowd. By listening to all the different voices, even the ones that disagree, you get closer to the truth. That's a powerful idea that could change a lot more than just medicine.